Good morning, everybody. My name is Rangsimant Ariyasuntorn from Class 6/1 Gimlet with Science Academy. Today, I will present about my celestial sphere model. That the first topic is about celestial equator and ecliptic. For first, celestial equator is the line that we expand the equator of Earth for infinite time and create celestial equator on the sky. And next is the ecliptic that have the angle about 23.5 degree from the celestial equator, and it is the orbit of Earth and the direction that we travel around the sun. So next is about the equinox and daytime. For equinox, there are two times a year that day and night equal together. That is vernal equinox around 20 to 21 March, and autumnal equinox that is around 22 to 23 September, and they both have declination for 0 degree. And next is about the solstice. First is summer solstice. It happens around 20 to 21 of June every year, and it is the day that the daytime is longest in the year. Next is about winter solstice. Winter solstice is the longest night time of the year that happens around 21 to 22 December of the year. They both have the opposite side of declination, that is summer solstice has 23.5 declination and winter solstice has minus 23.5 degree of declination. This is the reason that sunrise and set range is higher in summer season that make the longer day, and the range of them shorter in the winter season to make the longer night. We can conclude that higher declination make more different time between day and night. Thank you.
Different point and plane of equatorial coordinate system in the celestial sphere. We have the reference point at the vernal equinox, where the sun crosses the celestial equator, moving northward. This is the origin of the right ascension, or RA. And the reference plane that we use is the celestial equator, which is the projection of the Earth equator onto the celestial sphere. And we have the two things, the declination and right ascension. The declination is the distance of the celestial object north or south of the celestial sphere equator. We measure it in the degrees, varying from the 0 to plus or minus 90 degrees. It is the same idea as the latitude on Earth. And the second is the right ascension. This is the angular distance we measure eastward along the celestial equator from the vernal equinox. Then we use the unit in the hour to measure it. For the 1 hour stands for the 15 degrees from the vernal equinox. So, identify declination using the horizontal coordinate. The declination is equal to the altitude of the star at the local meridian plus observer latitude at 15 degrees for Thai, minus 90 degrees. The example is the Sirius or Alpha Canis Majoris. Altitude at the local meridian is at 58.28 degrees, and the observer latitude is 15 degrees. So the declination is 58.28 plus 15 degrees minus 90 degrees equal to 16.72 degree declination. And for the second example, Vega or Alpha Lyra, the observer altitude at the local meridian is 66.22 degrees and the latitude is 15 degrees. So declination equals 66.22 degree plus 15 minus 90 equal to plus 38.78 degree. And the last one, identify the circumpolar star. The circumpolar is the star that never set in every time. So we need to find if the declination is higher or equal 90 degree minus the observer latitude. So for Thailand it is 50 degree north. So the declination is must higher than 75. For example of the Sirius is not the circumpolar star because the declination is lower than 75, also weaker. So the star that is the circumpolar star in Thailand is obviously Polaris because the declination is 89.26 degree. So it's rotate around the almost at the NCP, and it never set at Thailand at any time. Thank you for listening our presentation.